Wormholes. You've seen them in movies, right? They're this incredible promise of unlocking the whole universe. But what are they, really? And could something like that actually exist? All right, let's jump right in and try to separate the physics from the fantasy. So first things first, forget what you've seen in the movies. A real wormhole probably wouldn't be some flat, swirling vortex. Nope, the physics tells us it would be a sphere. Just imagine that, a shimmering, perfectly round window just floating there in space. It might even look a little like a black hole, but there's one massive difference. See, unlike a black hole, this isn't a one-way trip to oblivion. This sphere would basically be a window. Light from the other side could just pass right through. You'd get this incredible, even if it's a little warped, view of a star system light years away, or another galaxy. And the thing is, it's not just a window to look through, it's a doorway. Which, of course, brings us to the biggest question of all. Is this just, magic with some fancy physics words thrown in? Or could these shortcuts through the very fabric of space-time actually be a real thing? Well, to even begin to answer that, we've got to go back to the guy who completely changed how we think about the universe itself. Okay, so before we can even talk about a wormhole, we need to get our heads around the kind of universe we're living in, because it's not the stiff, boring place we used to think it was. We have to look at it through Einstein's eyes and his mind-blowing idea that space-time bends. I mean, this was a huge shift in thinking, right? For centuries, people just assumed space was like a rigid, unchanging stage, like a hardwood floor, and planets and stars were just actors moving on top of it. But then Einstein comes along and says, nope. It's more like a giant waterbed. The actors, the sun, the planets, they're actually bending and warping the stage they're on. So if space-time is flexible, if you can bend it and stretch it, well, what else can you do with it? Could you tear it? Could you, patch it together in a weird new way? That very idea, that flexibility, is exactly what cracks open the theoretical door for something like a wormhole to even be possible. All right, so let's talk about the very first wormhole theory. This thing came straight out of Einstein's own equations. It's called an Einstein-Rosen bridge, and it's got this super fascinating link to those other cosmic monsters, black holes. Okay, try to picture this. You start with your flat sheet of space-time. You put something really, really heavy on it, and it makes a dent. Now, imagine you squish that heavy thing down, smaller and smaller, until space-time gets so bent out of shape that it just collapses. You get a black hole, right? With its event horizon, that famous point of no return. But here's the wild part. The math says that might not be all that happens. That very same collapse could also create a bridge. A bridge to where, exactly? Well, according to the theory, to a whole other parallel universe, a kind of mirror version of our own. And on the other side of this cosmic bridge, you wouldn't find a black hole sucking things in, you'd find a white hole constantly spewing things out. It's a really neat, symmetrical idea. So the question is pretty obvious, right? We've got a bridge connecting two universes. Can we just hop in a spaceship, dive into a black hole, and pop out the other side in a parallel reality? Yeah, unfortunately, the universe says no. A hard no. The physics here is just brutal. This bridge is incredibly unstable. It basically pinches itself shut in the middle way faster than anything could ever cross it. So if you try, well, you don't make it to another universe. You just don't make it. So the original model is a total bust for interstellar travel. If we're going to zip across the cosmos in the blink of an eye, we need a totally different kind of wormhole. We need what scientists call a traversable wormhole. One that we could actually build and, use. So if we were making a checklist for a useful wormhole, what would be on it? Okay, number one, it's got to connect two places in our universe. Let's say from Earth to Jupiter. Number two, no one-way event horizons. We got to be able to go in and come back out. Third, the gravity inside can't be so intense it would rip a person apart. And most important of all, it has to stay open long enough for us to actually get through. And yeah, that last one, that's the real killer. No matter how you create a wormhole, the immense force of gravity is just going to try and slam it shut instantly. Think of it like trying to dig a tunnel in loose sand. It just collapses on you. We need something to physically prop it open, to fight back against gravity itself. And the solution that physicists came up with is, well, it's something straight out of science fiction. It's called exotic matter. Now, this isn't antimatter, it's something way, way weirder. It's stuff that would have negative mass, Think about it. Everything we know, people, planets, stars, has positive mass, so it pulls stuff together with gravity. Exotic matter would do the exact opposite. It would push spacetime apart. It would literally create anti-gravity. As wild as that sounds, there might actually be a loophole in the laws of physics. Turns out, the vacuum of empty space isn't really empty. At the quantum level, it's this boiling, chaotic soup of virtual particles. And some scientists theorize that we might be able to harness the energy from this quantum foam, creating the kind of repulsive force we need to prop a wormhole open. Okay, let's just imagine for a second that we solve it. We find some exotic matter. We build a stable wormhole. Humanity's future among the stars is secured, right? Well, there's a dark side. A profound, universe-breaking catch that comes with rewriting the rules of space. First, let's just live in the dream for a second. We could wire up the whole solar system, then the galaxy. Earth could become this central hub for a vast interstellar civilization, with colonies light years away that are just a quick trip through a portal. It would be the single greatest achievement in all of human history. But here's the problem. According to Einstein, space and time are fundamentally linked. They're space-time. So when you create a shortcut through space, you might also be creating an unintended shortcut through time. And that's where things get really dangerous. And this leads us to the ultimate paradox. A traversable wormhole isn't just a space folder, it's a potential time machine. This could violate causality, that basic rule that an effect can't happen before its cause. I mean, imagine going back in time and preventing your own birth. It's a paradox that could unravel reality itself. And it's exactly why many physicists believe the universe must have some law that makes stable wormholes impossible. So where does that leave us? Are they shortcuts to the stars, or a gateway to paradoxes that would break the entire universe? For now, the answer is somewhere in between. They're a beautiful possibility, a tantalizing solution that works perfectly in the equations that describe our universe. The real question for the future is, will they ever move from the page and into reality?